Hello guys, in the last chapter we are going to talk about solvers in the Simulink. That what methods are used for solving the equations in the Simulink. As we saw, Simulink works on the basis that we have a system that the system is modeled by mathematical equations. Then we can simulate the mathematical equations in the Simulink. It means that Simulink works based on the mathematical equations of our system. So I want to give you some explanations on solving such equations in Simulink. First, I'm going to talk about equation solver configuration in Simulink. Then how you can change its solver. Then we have model configuration parameters window, which is the most important window in this section. Then we are going to talk about types of solving problem methods in Simulink. Then solver with fixed time steps, solver with variable time steps, continuous and discrete solvers, and finally the sampling time. Here, before starting the explanations, I want to let you know that Simulink has different solving methods for different dynamic systems. For example, if the system becomes complex, some specific methods will be used in order to decrease the simulation time. So we use these solving methods in order to decrease the simulation time. Because when the system gets complex, for example, when we want to use a modifier algorithm in a complex system, definitely the process of simulation takes a long time. Sometimes days last to run the system. Now, in order to accomplish these codes, it's better to know equation solving methods in Simulink. Also, it's better to know their different types. So in doing so, in order to know this, see the solvers, we go to the Simulink and model configuration parameters. We have it here. Just click on it, and this window opens for you. Here in simulation time, we have a start time. Also here we have stop time. Now it is on 10 seconds. These are the solver information. Now, okay, here we have solver options too. We have type of the solver. Now it is on variable step, but you can change it to fixed step too. Now, I think you have a question mark in your mind. What is the difference? In the fixed step mode, the model is solved in fixed consecutive time interval. It means that the step time amount which is chosen for simulation is same from beginning to the end. If the simulation time takes a long time, we have variable step mode. In the variable step time amount which is chosen for simulation changes along the simulation. For example, when the levels of model are changing fast, the step time decreases and the simulation process implements faster, or the work steps decreases while the accuracy will be constant. Pay attention that the simulation accuracy is very important. For example, when you work with Simulink and have a discrete system, if you choose the sample time too big, the output will not be acceptable. Or about continuous systems, we have a relative tolerance. If we increase the tolerance, definitely the simulation will be invalid. So if you decrease it, the simulation time increases, but the accuracy increases a lot too. Here you can see the solvers. We have a discrete solver. Discrete solvers are divided into two groups: fixed step or variable step, and discrete or continuous. The discrete method is used for those systems which are time discrete. In this way, we can use both variable step and fixed step. But in continuous, the systems are not discrete, and we want to run that system continuously. About these types of methods, you can see different equation solving methods. Just here, I want to tell that in default mode of Simulink, this type of solving is on ODE 4.5. This is default mode. But the best one is ODE23TB. It both decreases the simulation time and its accuracy is almost the same as other methods. This method is common among users because the simulation time decreases. So there are 4 methods in equation solving. One is the variable step. Here, when I set it discrete, you can set your maximum step size because step time is variable. Because the steps are chosen variably, you can set a maximum of 2. So more than that, steps won't be selected. Another way is fixed step. In discrete mode, you can enter the amounts here. Then fix a step in continuous mode, which you can specify the time of step. You can set other data about equation solving here. The other part here is data import export. You can set an initial step for your system, or you can transfer its final state to the MATLAB workspace and save it. Also, you can set an input to your system. There are other parts here. We have optimization, diagnostics, and code generation. The other point is about saving the project. As I showed you before, you can use SLX and MDL suffixes. In old versions, we had MDL, but in new versions, I think after 2012, SLX added too. Pay attention that if you save a file in SLX format, you can't run it in old versions. And the systems which saved as MDL, you can use them as SLX and vice versa. So MDL is for old versions and SLX for new versions. So in the future, maybe the MDL suffixes removed. Because here about the SLX, there are some advantages. For example, the size of SLX is lower than MDL, and it increases the saving and loading speed. Okay, my friends, we have done. I hope you found this course effective and useful in your education, in your work projects, in your working projects. Don't worry, I'm here. If you have any question or any comment, just email me or put your comments. I'll respond to you very, very, very fast. Bye-bye.